Welcome back to another HVAC-Engineering-Techie video. Today's video is part 3 of my journey through the carbon puzzle. Today we're going to talk about future priorities. What should we be doing based upon what we learned in part 1 and part 2 of the previous videos. Remember, this video is intended to give you more knowledge about the subject we're covering, and hopefully these do that. Certainly helped me as I spent my year and a half going through this journey. Please remember to become a subscribing member by hitting the subscribe button down below. Give me a thumbs up. I appreciate that. And please share with your friends and neighbors. Maybe they would like to learn something about this subject also. So thanks for watching, and let's get started on the video. So what is going to be our best path forward for electrical generation production, and what things should we be doing in general to make that all better instead of what we're doing now, which is running down the road? Well, here's some of the scary parts. The U.S. electric demand could rise 128 gigawatts over the next 5 years, driven by data centers and manufacturing growth primarily in 6 regions of the country, according to a report published Thursday by Grid Strategies. It's part of the electrical infrastructure's publications. The shocking estimate represents a 5-fold increase in load growth forecast over the past 2 years, the firm said. So basically, they're predicting. Normally, the normal prediction was half that, a 75 gigawatt production. What's the problem with that, you say? We haven't been building any big power plants. I'm talking about 1,000 megawatt power plants. We've had one nuclear power plant come online the last 10 years. No big gas ones at all. So it's a problem. Best path forward. So here's a projected growth. So from our data, we said we had 4.1 gigawatt hours per year. And the existing power plants are 4.746 gigawatts. The 5-year growth is predicted to 532, which is 75.36 gigawatts. That's 75 new 1,000 megawatt power plants in the next 5 years. 75 of them. And that's mainly in 6 different areas. So if it's a 3% annual growth, which was their normal projection, now this one I just read you was almost double, that's 5%. Over the next 5 years would require 75 new 1,000 megawatt power plants in the U.S. Now, we've only done one in the last 10 years. Where are we going to build these 75 major power plants? Major growth in 6 regions would equal 12 1,000 megawatt power plants in each region. Can you imagine building 12 major power plants in a region like a 3 or 4 state area? This is a problem. The power people are scratching their heads. They're not sure how they're going to get there. And the people that are promoting everything else that requires it just got their head in the sand and said it doesn't matter, it'll happen. I don't know. This is a train wreck in process. So the existing power grid is not large enough to transmit that much power across long distances. So these power plants are going to have to be built close to the load. And that's something we haven't done in the past. We put the power plants out of town. We want to see them and transmit the power in, which involves line loss, cost, and infrastructure. Well, this is actually saying we can't do that. We've got to do something else. Some growth projections have been modified from the 75 gigawatts to 128 gigawatts, which would mean a lot more power plants. Due to regulatory hurdles and environmental concerns, building large traditional power plants has significantly decreased in the U.S. People that are concerned about health, which I agree with them, but we've just killed everything that we do. We've killed all the major petrochemical plants. We've made the permit process so difficult that it takes people forever. Now remember, these things only happen if there's profit involved. If you make it so there's no profit, they're not going to happen. Because remember, the government is the very worst selection to try to do anything. Government can make decisions on where we're going to go, but they can't help get there. They're not capable of doing that. They can't run a business. Most people in government have never been in a business, have no idea how this works. And that's kind of unfortunate. Only one nuclear power plant is brought online, and that was just a cell of an existing plant in the last 10 years, which is unfortunate. We could use more of those. Now, a lot of people are against nuclear power because it's so dangerous. But I've actually worked in a nuclear power plant. I've worked at a coal power plant. I've worked in gas power plants. I've done a lot of assessments of telling them how good their facilities were and how to financially assess their systems so they know how they need to spend money and whatever. And so I've been able to compare those three different types of plants. Now, nuclear plant, the actual nuclear deal is kind of scary. Problem areas are very, very small. They've had very, very few. And Arizona has one of the largest nuclear plants in the world. They have 3 major lungs doing 4,000 megawatts. They has been in operation since 1975 or 76, something like that. And it's basically stored all of its used fuel on site in the parking lot. They have these 12-foot diameter concrete casks, they're about 20 feet tall, and they have like 10, 12 of them out there, and that's provided the fuel for that huge plant for all of these years. And if we were smart, we could actually use that fuel to create other fuel and get rid of it. But we haven't figured that out yet. Politically, we haven't figured that out. So basically, to me, in my way of thinking, nuclear, if you want to do low carbon, nuclear is the way to go. Because you can build a nuclear plant, it has a long lifetime, it has a great uptime, and it doesn't use any burning fuel. The burning fuel is all at the small level that it doesn't produce gas. So to me, that would be the way to go, but other people have to make that decision. Most new power generation capacity in recent years comes from renewable sources like solar and wind, often built in small, distributed projects, developed and built without regard to lifetime or uptime. This is a problem. I understand the excitement of building solar. Like I said, I've been involved in the solar industry for a long time, but this is not the way to go to secure our energy future. We must look to other ways, and that's what we're here to discuss today is, what are these other ways? Obviously, these issues are going to collide with the demand growth of our power infrastructure like now. I mean, next year, you're going to really start to hear this. And in 5 years, it may be a crisis. Because remember, power plants don't come easy. It takes a year or so to design a gas power plant and a couple of years to build one. A nuclear plant takes 10 years to plan, 20 years to build, or 10 years to build. So they take a long time. We need to look in the future. So we need long-range planning instead of panic reaction. And unfortunately, I think we're going to be driven towards panic reaction. But still, we need to plan for the long term. Reacting only to panic growth will lead to poor choices of what kind of power plants to construct that will lead to higher costs and more future disturbance. Long-range roadmap needs to be established to concentrate on meeting the immediate need without causing long-term disturbance in our power infrastructure. Using a middle-of-the-road philosophy to prevent radical approaches that are feasible in the long term or for cost, achieving a radical goal while going bankrupt makes no sense. So whatever we come up, we should be middle of the road and should be practical in cost. Now, we still want to watch pollution and we want to watch CO2. We don't want to go crazy with producing that, but we mean to understand that we need to be the middle of the road to be able to help our country grow. Because where we're at right now, we're doing nothing. And so we're just arguing with each other, and that isn't going to work. So, I'm a commissioner, and I've been a mechanical contractor, I've been an engineer. We need to be meaningful in what we're doing with this. We need to be middle of the road. We need to do this correctly and not just jump off at the nearest thing. So I'm again that middle of the road, stay out of the bar ditches on either side. For environmental impact, focus on reducing pollution and carbon capture where feasible. We're trying to concentrate on carbon, which is hard to do down to the input level. So this is the problem. If you go from 100% to zero, that zero, from 20% to zero is really, really hard and really, really costly. If you just want to reduce CO2, it's not that costly and still will help us get where we're going. And yet people refuse to do anything, which is not reducing anything. So we need to do that for environmental impact. For cost focus on equivalent annual cost, EAC. It's the best way to evaluate between alternatives. Evaluate which type of plants to construct. Verify that the users that are driving this large growth also pay for it and not move the development costs to the government or the general public. That's a concern. Because if our utilities start ramping up to provide those data centers, it means the costs are going to go up across the board, and that should not happen. So I think our roadmap needs to have future. We need to plan for our future. Continuous investment for fusion power. I think we need to keep the pressure on to develop fusion to get it down the road further. Investment for developing coal hydrocarbon conversion. Now, like I told you, I've worked in nuclear power plants, I've worked in gas power plants, and I've worked in coal power plants. And my experience tells me we should not be burning coal at all. And it's not because of any political statement. It's just nasty. It's dirty. I don't know how the people work there. I don't know how they survive working that environment. There are coal dust everywhere. Everyone has breathing apparatus because it is so dirty. I seen brand new air conditioners installed, and in 3 months they look like they were 20 years old. I mean, there's dust clinker everywhere coming out of the stack. Even though we had full carbon particulate capture, we had scrubbers on everything. It's still not perfect. When they maintain it, it gets around it. It is nasty, dirty. We need to take the coal. Coal is a great resource, but we need to do other things with it besides burn it. We need to convert it to syn fuel. We need to do whatever we can to make coal beneficial to us, but burning it is not one of them. Coal is the most polluting. Coal is the most CO2 production. There's all kinds of reasons not to use coal. Now, I understand that that's going to hurt the coal industry, but that's why I'm saying let's take a long-term investment into making coal into something else. And we can do that. We've got the coal reserves and we've got the resources to make this happen. Long-term, 25 years. Plan and construct new nuclear sites. Let's get that started. Now, Bill Gates has financed, or is a part of a financing team, for a new nuclear site that's a smaller hybrid reactor, which would be really good news if this could come off, because it is so much better for waste fuel, and it can produce quickly. It can come aboard in 10 years or so. So this is something we need to do. Plan to construct more hydroelectric sites. This is something we've been trying to shut them down instead of build them. I know that the solar project in our area is now planning a new lake to improve our water storage and to put hydroelectric on that. I think that's a good thing. Where we can use that, let's do that. Plan to construct more geothermal sites, somewhat restricted on where and what those are, but where we have hot earth, let's use that to produce energy. Continuous pressure to improve fuel and electrical use performance. We should never take our eye off the performance efficiency of transportation, the performance issue of our buildings and our stock, and we just need to continually do better, better, better. Why would we not? You know, if you can build something better that uses less fuel, produces less carbon, why would we not do that? The problem we're having is people mandating zero, like the net zero building deal. The net zero, I unfortunately have to tell you, is a fake deal, because it's not. You know what it sounds like to us in the residential area is that it means the building uses absolutely no energy, it uses no water, and it produces no carbon in the atmosphere. All that's totally false. The definition has been politically assigned to what net zero is, and it's not that. It just means it's not using anything outside. It's not got any energy. It's providing its own energy, not water. And they still have green energy deals attached to it, which should not happen. Which means I could give you a piece of paper that says you're buying green energy so you don't have to do it yourself. Again, we should be concentrating on making the best buildings we can, and net zero needs to go down the wayside because you're spending a whole bunch of money and for political reasons and really not getting any benefit or not much benefit. Sometimes it's negative benefit. I have built platinum buildings before, and every time I build a platinum building, I ask the owner, how many more of these are you going to build? And the answer has always been none, because it was very painful, it was very expensive, and the benefit was not worth the results. Continue to develop sustainable renewable energy and reasonable uptime and lifetimes. We need renewable energy, but we need to be smart about what it is and not just say it's a panacea for everything and just dump a whole bunch of money in it and watch it crumble and burn as time goes on. Short term, 5 to 10 years, let's construct more gas sites. You're going to need more gas power plants, so let's plan for them and get them started and get it going. Convert coal power plants to gas or syngas gas plants. Don't burn coal. Please don't. Figure out how to get rid of coal. And then help the coal miners and people by figuring out what to use coal for that's helpful. I mean, if we can effectively use syngas, then we could produce natural gas sites that actually burning syngas, which is basically hydrogen, which would be a good thing. Continue to develop carbon capture technologies. Like I said, carbon capture is not totally reliable in my mind, because if you just dump a bunch of carbons in the ground and if an earthquake and it cracks and it releases to the atmosphere, you've gained nothing. Continue to promote rooftop solar. Now, I like solar rooftop. And you say, well, what's the difference between grid-tied solar and rooftop solar? Well, grid-tied solar are very large projects that have line loss, have infrastructure loss getting the power to you, and has utility profit built in. So to me, having rooftop solar that is yours, you own it, and it goes directly to your home, directly to your business, it's much more efficient than grid-tied solar collector, and it's an asset you own. So you can decide when to use it, when not to use it. You can decide when it needs to be replaced, whether it's worth it or not. All those decisions are yours and you're to make. The only thing about rooftop solar right now that's broken is the government has tax rebates, utilities have tax rebates or utility rebates for that, and the contractors who are selling solar are not governed, and they're running wild. It's the Wild West for them. And they've been selling them by basically telling homeowners, okay, I can put solar on and you don't have to pay a dime, because you'll pay for it out of the savings you're going to make by having solar on your roof for so many years. And the people sign off on it, but the problem is it doesn't turn out that way, because the people selling you solar are not doing it correctly. They're putting collectors on the north sloping roofs. Now, I had salesmen come by to try to sell me solar, and of course they kind of walked into a trap, because I said, well, tell me about where you place collectors on north roofs. And they're trying to tell me, well, they collect energy. And not quite as much as the ones on the south roofs, but they collect energy. And the truth is, it's all a matter of the angle of the light shining on a collector. And if it's diffuse light, which has no direction, the energy is very, very low. On a flat roof, a perfectly flat roof, a collector might collect 25% of what it was if it's correctly sloped to the latitude of the site. But you put it on a north sloping roof, it can go down to almost nothing, because the light source glances off at maybe 2 degrees. So maybe 2 or 3% is direct sunlight. So, and the people are using those, and so I finally pinned him down. I said, why do you do that? He said, we're maximizing the utility rebate. Well, that ought to be, the contractors need to be stuck for that. I would propose that by government, I don't like mandates, but a government mandate that all solar collector contractors have to guarantee the results. If they tell a customer it's going to pay back this much, they have to guarantee that if it doesn't happen, they have to pay the bill. It's the only way to stop that nonsense. You know, I've seen people put all their collectors on a north sloping roof, which is absolutely insane. And it's because these people are getting away with anything and no one's watching them. Specific changes for the energy environment. Transportation. Continue to support electrical vehicles without industry mandates. Let the free market decide which type of vehicles are desired. By mandate, I mean you can't mandate manufacturers that they have to have electric vehicles 100% of their fleet in 10 years, or whatever it is. That's foolish. You're going to drive them out of business. And that's absolutely politicians at their absolute worst. I would also say don't do tax rebates. But maybe you want to do tax rebates if you're trying to establish an industry. But once an industry established, which I think it is, it should be able to stand on its own. Also, I think that we need to come up with a reasonable way to charge road tax on electric vehicles. You know, right now, we put a tax on fuel. Well, they don't use fuel, but they still use the roads. So we need to have a mileage tax. That electric vehicle has to pay a mileage tax where a regular gas fuel pays it on fuel. It's not right for someone to be able to use the roads for free when others have to pay the bill. That's not what we're all about. Promote alternate fuels, liquid natural gas, hydrogen, ethanol, and clean diesel. These are all fuels that can help us reduce our CO2 and get where we want to go. Concentrate on actual final efficiencies and low pollution. We need to continue to build the most efficient machines we can and the lowest pollution machines we can. Why would we not? You know, if we can build a car that gets 30 miles to the gallon, why would we not do that? We shouldn't be building ones that only get 10 miles a gallon. We should build them that get better and better, and I think hybrid is the answer for the near future. Build hybrids that get 30, 40 miles a gallon away from the 15 miles a gallon, and that would reduce our CO2 significantly. Instead of saying, no, it has to be 100% electrical. That's foolish. That's religion again instead of science thinking. Residential buildings continue to support rooftop solar and energy storage. Require contractors to guarantee proposed production, like I said. Now, I personally haven't done it, but the one way I had a young man that worked for me, and he had a Tesla electric car, and he had rooftop solar, and he had battery storage in his garage. So he basically produced all the electricity his car needed at no cost. He never had to buy fuel. He never had to pay for the electricity to run his car. That was a significant savings to this young man, and I thought I was impressed. That's the way to do it. Continue to support high-efficiency construction for both new construction and renewal projects. Always keep pushing that our residential buildings are more energy efficient and more livable than what they are today. Commercial buildings continue to support rooftop solar and energy storage for commercial. Continue to support high energy efficiency construction for both new construction, renewal, and retrofit projects. We need to keep building more efficiently. Support a national effort to identify the total entrained carbon in building materials and equipment so low carbon solutions can be accurately identified. Right now, we do not know. If you go out there and try to find how much carbon is entrained in a solar collector, you cannot find it out. Some people will say 240 pounds. And, that's not right. Because think about it. If you buy a collector out of China, China mines the coal, builds power with coal, smelts aluminum with coal, powers all their plants with coal. They build a collector, they sell it to you, and they put it on a ship using diesel fuel. And it gets here to America using diesel fuel, and then it's delivered to you using diesel fuel. And you think that collector has no carbon in it? That's foolish. It has a lot of carbon on it. So we need to understand that to be able to make better decisions. Should be able to decide, okay, a collector built in Ohio costs $10 more, but has this much less carbon in it. This is a better deal. You need to know that. Stop supporting green energy, which supports non-sustainable grid-tied solar and wind farms due to short uptime and lifetimes. The green energy is not a good deal. That's a false narrative on when it comes to actually being green. Promote continual energy use improvement over time. In other words, most of our buildings, you build a brand new building, the minute you finish it begins to degrade, its performance begins to degrade over time. And that's normal, except you should have operator staff that understand how to make it better and better and better, not worse and worse and worse. And there is a way to do that. And we should be doing that all the time. Industrial buildings continue to support high energy efficiency for both new construction, renewal, and retrofit projects. Now, industrial buildings really shouldn't be using solar. I mean, if you're building a smelter, you're going to have gas. There's no other option unless you want to burn coal, and I don't recommend that. So you're not going to be able to do that with a heat pump, let me tell you. So industrial is off the books as far as that. You're going to have to burn gas. Concentrates on lower total pollution, because this is where our industry pollutes, is in the industrial sector, and we need to stop that. Lots of pollution. Data centers and large energy users. Promote dedicated power plants for large energy users such as data center campuses. If you're going to put 5 big data centers in the same area, all using 60 megawatts of power, they should have a dedicated power plant just for the data centers. Because there's no reason to hook that to a grid. It's just going to skew that grid all over the place. So make a dedicated power plant. That makes sense to me. And the power and construction operating costs should be borne by the user. So the data center should pay for the construction of the power plant, the fuel for the power plant, the use for the power plant, as long as they're in business. I mean, it makes sense. That way it won't skew the utility rates for other users. What are the best options for energy and CO2? Here's my chart from the previous session. I think, number one, don't burn coal, and I've explained that enough. I think coal is not healthy. Point of view solar, I think I'd like to see that continue, even though it has short lifetime and short uptime, but it's right there with the user, and he can make the decision. Look at gas with CO2 capture. That is by far the sweet spot for building a new plant. New nuclear sites, I think, is a must for the future. We must build our baseline with hydroelectric and build our baseline with nuclear, and then let the others fill in around it. Advanced nuclear, geothermal, if we can find more sites that would be beneficial, let's do that. And then, of course, gas sites are going to have to be the go-to for the short term to be able to keep our power production up. There's no answer. We can't do it any other way. If we don't build short-term gas plants, we will fail because we won't have the infrastructure or electrical power to generate what's coming our way. Coal conversion with synth gas or whatever we can do with coal. It has hydrocarbons, and we need hydrocarbons. We can get them out of coal. We just have to figure out how to do it in an economic fashion. Ethanol. We need to continue producing ethanol. It's a fuel. It can help us, rockets, it can help us do a lot of stuff. We need to keep doing that. As long as we don't need to, if we don't need to eat the corn, let's make ethanol. And increase system efficiencies. That should be our mantra. Be as efficient in everything that we possibly can be. I would recommend mainly reducing pollution and increasing efficiency, and not just complain about reducing CO2. I think it misdiagnoses what we need to do. Let's be the middle of the road. Let's get things done, and let's become better and better at what we do. So we've covered the 3 parts, and that's my total journey through carbon. I hope that was enjoyable for you. I hope you got some information out of that maybe you can use. Please share these videos with your friends, and I hope you have a great day, and I hope you enjoyed them. I've enjoyed bringing them to you. So have a great day. I'll catch you on the next one.